In this video, I want to address some problems that were towards the end of the packet, and these have to do with the concepts of present value and future value, which I think are as important as anything else that we've studied in our financial math unit. Now, we've introduced them as A angle N and S angle N. A angle N for present value and S angle N for future value. And I've shown you how to use the calculator functions for these, but it's also important to know what they mean in a more mathematically rigorous sense. So what I'm going to do is I'm going to show a timeline. Usually this kind of always comes down to a timeline, starting at 0 and going up through n. And of course the previous year would be n minus 1, and the one prior to that is n minus 2, and there's a certain number of years in between. Now these do not have double dots on them, which means that the payments come at the end of the year, and these are $1 or 1 money unit payments. And if we have payments of a different amount, we just multiply it by the A angle N or the S angle N notation. Now the A angle N, that is the value at the beginning of this series of payments at time 0. And S angle N is the value at the end of the series of payments. Now hopefully one thing we can see is that the value at the end is going to be greater than the value at the beginning. The reason for this is because as things earn interest over time, well, clearly later time periods where there's been more time for interest to be earned, S angle N, all other things being equal, is going to be bigger than A angle N. Because if our interest rate is greater than 0, we're earning interest, future value will always be greater than present value. Now, one more thing we can compare this to, how does this compare to N? Well, if you consider what N is, you can think of N as the number of payments, but you can also think of N as the value of each payment, or the total value of the payments that is not time sensitive. You can think of N as the non-time sensitive value. I'll write this out here. The non-time sensitive value. The illustration that I use is suppose you're setting aside $1 at the end of each year and putting it not in an investment or in a bank, but in your mattress. Well, let's say N is 10, for example. You stick $1 in your mattress at the end of each year. What are you going to have at the end of 10 years? Well, you're going to have $10, and no less and no more. So let's consider, where does N fall in this, as far as like greater than or less than, in comparison with A angle N and S angle N? For example, N in comparison to future value. If you put the money in the mattress, it's obviously not going to be worth as much at the end as if you had put it into an interest-bearing account. So what we can say is that S angle N should be bigger than N. So now that leaves, where is A angle N in comparison to this? This one's a little bit more subtle. Think about it this way. If you wanted to be able to withdraw $1 every year, at the end of every year for 10 years, there's two ways you could do this. You could stuff away $10 and put it into your mattress, and then very dutifully, very diligently withdraw exactly $1 at the end of each year, and that definitely is a way that could work technically. But how much would you need in order to do that? Well, you'd need the full $10. Why would you need full $10? Well, because that money is not earning any interest at all. What if the money that you have in the beginning does earn interest? So in other words, it earns interest for a year, and then you pull out $1, but then whatever is left earns interest for a year. It's not as much as you had before, but there's still something earning interest there. And then you pull out another $1, and you continue this for 10 years. Well, it should be then that this value, which is otherwise known as A angle N, you do not need as much money to enable that to happen. So A angle N is going to be less than N. So if we were to look at the comparison of these, the smallest value is going to be A angle N, and wedged between that and S angle N, somewhere in there is going to be N. Now let's consider what A angle N and S angle N actually mean and how they are related to each other. So here's our timeline again, and remember that A angle N is the value at the beginning of this timeline, and S angle N is the value at the end of this timeline. Let's first consider what S angle N looks like in its long form. First of all, consider the last dollar at time N is worth how much at time N? Well, it is worth exactly $1. The dollar at time N minus 1. Well, between N minus 1 and N is 1 year of earning interest. So within that year, it's equal to itself plus the amount of interest earned. The previous payment of $1 at time N minus 2, it had 2 years or 2 interest periods in which to earn interest. That value equals 1 plus I squared. The previous one, the one prior to that, it got a chance to earn 3 years interest. And on and on and on. Now, it may be a little easier if we're going to go back and see how far back does this go. It doesn't go all the way back to 0, as you notice, because there is no payment at 0. There is a payment at 1, which is at the end of the first year. How many years has that very first dollar had to earn interest? Well, it has had N minus 1 years to earn interest. So I'm kind of working backwards and kind of meeting in the middle. So, and then the $1 at year 2, well, it had 1 fewer years to earn interest, so that's going to be N minus 2. And then at time 3, we have 1 plus I raised to the N minus 3. So that is one of the things that is equivalent to S angle N. Now, this is also a geometric series. If you remember geometric series, if you look at geometric series has a first term. In this particular case, this first term is 1, and it has a common ratio. Well, what happens each time is we're multiplying by a 1 minus I. That's our common ratio. And the number of terms is n. How do we know there's n? Well, the powers go up to n minus 1, which means there's n minus 1 1 plus i's in there, and then there's the first value, which is a 1. That adds up to a total of n values. So the sum of this series is 1, which is the, well, let me first write the formula. A1 times r to the n minus 1 over r minus 1. Now this is one form that the geometric series formula can look. There's more than one way this can look. Let's make that look like an A. I think I just smudged it. Okay, so A1 in this case is 1, and R is 1 plus I, and it's raised to the n minus 1, and that's all over, again, R is 1 plus I, and then minus 1. But notice that 1 plus I in our denominator, 1 plus I minus 1, what does that equal? Well, that equals I. And the 1 multiplied in the numerator, well, that doesn't change anything. That just leaves it as 1 plus I raised to the n minus 1. And that is, of course, the S angle n formula that we all know and love. Now let's consider what A angle n equals. So this time we're looking at interest being earned backwards. So the dollar at time 1. Well, at time 0, that dollar is 1 plus I to the negative 1. It has a value of 1 plus I to the negative 1. It is, if you were to multiply this by 1 plus I, you would get 1. The dollar at time 2, well, it took 2 interest periods to earn that one. And on and on and on, we have 1 plus I raised to the negative 3. And if we look up at the rest of these, it eventually gets us to 1 plus I to the n minus 3, or actually negative n minus 3. And then 1 plus I to the negative n minus 2 in parentheses, and then 1 plus I raised to the negative n minus 1. And eventually it gets us to 1 plus I raised to the negative n. In other words, that last dollar at time n, well, it took n periods to earn it. It took n periods for whatever your present value was. And this then equals A angle n. Now, I've rewritten things a little bit here, and I'd like to do a comparison, a term-by-term comparison. Notice, now, one thing you might notice that I've done is I've reversed the order of my A angle n terms, which I've done on purpose, so that I can set them up as parallels. What do we see that is, if we do a term-by-term comparison, for example, the first term, A angle n, is 1 plus I to the negative n. The first one on S angle n is 1. And then the next one we have, that should look like 1 plus I to the negative n minus 1. Basically, if we take every A angle n term and multiply it by 1 plus I to the n power, then term for term, we are going to get S angle n. And by the same token, if we take S angle n and multiply by 1 plus I to the negative n, what we suppose we would get? Well, we would get A angle n. Now, this video is already getting rather lengthy, and there's a whole lot more that I want to cover here, so I think I will stop at this point so that you can catch your breath, and we'll continue this in a future video.